Number 13. Suppose the demand for a certain item is given by D of P is minus 5P squared, subtract 7P plus 400, where P represents the price of the item in dollars. Find the rate of change of demand with respect to price, and find and interpret the rate of change of demand when the price is $12. Now, you'll notice they don't say average or instantaneous. So when they don't say either one of those, they mean instantaneous. So we've got to find the derivative, d prime of p, and then we have to find d prime of 12. So the first thing I need to do is find d of p plus h minus d of p, and then I'm going to divide that by h, and then I'm going to take the limit as h goes to 0. So you can use p, you could use x plus h, it doesn't matter. Just remember that if you use x, you're saying x is the price. They just use a p for price. So I'm going to first find d of p plus h. So that's going to be minus 5 p plus h squared minus 7 p plus h plus 400. That's minus 5 p squared plus 2ph plus h squared. Got to FOIL that out. Minus 7p minus 7h plus 400. And then the last thing is to multiply the negative 5. So negative 5p squared minus 10ph minus 5h squared minus 7p minus 7h plus 400. Now you'll notice when you do that first part of the difference quotient, this first part never simplifies. So the next thing we're supposed to do is subtract the original function d of p. That's a minus 5p squared, a minus 7p, and a plus 400. But look, we've got to minus it, so all of these signs get changed. And then when we combine, the original function terms have all been eliminated. This one will be a minus 400 here also. And then it will leave me with all the terms that are left will have an h in them. So I get negative 10 ph minus 5h squared minus 7h. That's because I have subtracted away all the originals. Now the last thing in my formula is I have to divide all these by h and then take the limit. So that's going to be a negative 10p, a minus 5h, and a minus 7, because I'm going to apply this h to all three of these. It's a common denominator for all three. So I have the limit as h goes to 0 of negative 10p minus 5h minus 7. And if h is going to 0, that term is going to be 0, so it's negative 10p minus 7. So that's the rate of change with respect to any price that's appropriate for the problem. Negative 10p minus 7. And so now we're supposed to find the change in the demand, that is the instantaneous rate of change of d of p when p is 12. So we're going to do d prime of 12, that's negative 10 times 12 minus 7, and that's negative 120 minus 7 is minus 127. Remember that this was the price, and this is what's happening to the demand. So the price is $12. So you're going to notice that all of these have a price of $12. And then this demand is decreasing because it's negative, so we're going to look for decreasing. So can't be the increase in the increasing. So it's when the price is $12, the demand is decreasing at a rate of about 127 items, okay, for each increase in the price of $1. So 127 goes here. Now we don't say the negative there because we've already got decreasing, so there's our negative. And if you notice, this slope, remember this, the derivative is the slope of the tangent, has a denominator of 1. So that's the increase in the price of $1, not the $12. The $12 is the exact price that we're looking at. The demand is decreasing at a rate of 127 items for each increase in the price of $1.